Hello, I'm Amreen Shahjahan, PhD student in architecture at Texas A&M University. In continuation to my first project of Building Information Modeling course, Project 2 will extend the functionality of parametric BIM by using Visual Programming Tool. In this Project 2, node-based visual programming interface, DYNAMO, has been used to control project parameters more efficiently. First of all, a well-defined advanced parametric model of Allianz Arena has been created to control massing of the stadium. And secondly, 3 experiments have been conducted to achieve automation in color changeability of stadium's external facade. These are some existing photographs of the arena, which is vividly expressing that these patterned color panels are being the major design features of the stadium from the very beginning. Now, the phase 1 of this project is creating parametric 3D mass of the arena. To create a single project parameter to control multiple families, Revit project file has been linked with the DYNAMO. And a set of workflow has been established to edit multiple parameters like length and width of the stadium mass. And this has been controlled with the integer slider. In addition to that, a DYNAMO math function has been introduced to control the proportion of the massing. Now, if I change the slider and hit run, then I'll be able to see the change of the massing. Let's try another option. The length and width of the stadium mass has been changed automatically. Now let's move on to the phase 2 of the project. In this phase, few sets of code has been created to automate the color changeability of external facade panels. Among 3 experiments, first one is change in color pattern through reading Excel data. Secondly, changing color in checkerboard pattern surface. And thirdly, changing in exterior surface color following solar orientation. This set of code has been created for 2 purposes. The left part of the code is to control the depth of each curtain panel component. Let's use the slider to see the result. The depth has increased. The rest of these scripts are for changing color pattern in external surface of the stadium following the data structure in Excel CSV file. If we see in detail, there are 8 curtain panels which has been linked with the DYNAMO, and a separate data structure has been created in DYNAMO file. And finally, the Excel CSV file will override the existing material of each panel by creating a patterned surface. Now, if we hit the run to see the outcome, then we will see that different pattern has been generated. This set of code will help to change the color of curtain wall panel following the checkerboard pattern by changing the material parameters. Let's see the result. DYNAMO code has helped to change the color of curtain wall panel in a checkerboard pattern. Finally, the last experiment is changing color pattern following the solar orientation. This set of code will change the color of the curtain wall panel based on the orientation of each surface relative to sun position at a specific time of a day. Let's set the location and time of the project. Then let's run the project. With the help of set DYNAMO code, first of all, surface vector facing the sun has been identified and complete curtain panel facade has generated in DYNAMO. Then gathering the solar orientation from the Revit project file, and with the help of vector dot, the color range will override the material properties. This is an example at 7 a.m. on 21st June. In this example, panels which are normal to the sun will be in red color and gradually turn in green based on the orientation. For instance, at June 21st at 7 a.m., the eastern side turns in red, whereas the western side panels are in green color. Now, if I change the sun position, the color of the curtain panel will change respectively. After changing the sun position at 9:45 a.m., The same panel color has turned from greenish to red. If I move the sun towards the west, then the western green facade will turn into red as sun position has changed. So at 7 p.m., panels at western facade has turned into red as solar radiation is directly hitting on the western side. On the other hand, eastern panels which were red has turned into green as sun position has changed. This experiment is very useful as this can be used in preliminary design phase of building to reduce the overall solar heat gain.